Okay. Um, so we're gonna throw together. Um, you guys need the notes still? Okay. Um, so we're gonna kind of throw together some of the things that you need to bring from Math 2 into Math 3 here. Um, we have special right triangles. The 30, 60, 90 and the 45, 45, 90 are going to be really important in this unit, especially when we're not able to use calculators. Everything's going to kind of come from these two triangles. And so you're going to want these side lengths memorized. But the nice thing, these are the only two triangles you have to memorize. Everything's going to grow from this. Pythagorean theorem, as we were starting to talk about, is going to be important. We'll use that just a little bit here and there. And then sine, cosine, and tangent is going to be really important and used almost in everything. And they are defined as ratios of sides of a triangle, right? And so you have an angle. We call it the reference angle. So if you have this triangle here, it's got to be a right triangle. And you got two other angles to look from, and you just decide, well, which one do you want to look from? And so let's say this theta is Greek letter. That's typically a variable that we use in trig. So say that's the angle we're looking at. Then the side across from it we refer to as the opposite side. Obviously, the longest side across from the 90-degree angle is always your hypotenuse. And then adjacent means next to, so the other side that's next to that angle is the adjacent side. Right? And so there's different ways to find ratios of those sides. There's actually 6 different ratios we can make. And so there's actually 6 different trig functions out there, but we're only going to look at 3 of them, the sine, cosine, and tangent. So sine is defined as the opposite side length divided by the hypotenuse length. Cosine is defined as the adjacent length over the hypotenuse length. And tangent is defined as the opposite length over the adjacent length. To help some people remember those, you may want to remember this saying, SOHCAHTOA, which S would stand for sine, O is opposite, H is hypotenuse. So those first 3 right there would give you the ratio for the sine, and then the CAH would give you the ratio for the cosine, and TOA would give you the ratio for the tangent. Just got to make sure you know how to spell that, right? So some people use that to help them remember these ratios. If you have another way to remember these ratios, that's fine as well. Okay. So these are the things that we're going to bring together. So here's our first example. We're going to find the value of x, and then we're going to find the sine, cosine, and tangent of angles A and angles B. And so to find a side length, when we're given 2 side lengths in a right triangle, that's when we use Pythagorean theorem. Is x the hypotenuse? No, one of the legs, right? And so the Pythagorean theorem says, well, you square both the legs and add them up. So x squared plus 9 squared. And that sum is always equal to the hypotenuse squared. And then we can use that to solve. So x squared plus 81 is, what's 15 squared? 225. Okay. And then to solve this, we're going to subtract 81 from both sides of the equation. And so what is 225 minus 81? 144, which happens to be a perfect square. And x, we're going to take the square root of both sides. And typically, if we didn't have a context here, x could be positive or negative, right? But we do have a context. We're talking about a side length of a triangle. So we're going to ignore the negative answer, and we know x is positive. So when we take the square root, we're only looking at the positive square root, which is what? X is 12. All right, so now we have our side lengths 9, 12, and 15. Often you'll see this on these problems. There's a, the Pythagorean triples, but one of them, there's a 3, 4, 5 right triangle. Comes up a lot, and then if you scale that out, which is what we have here. So if I multiply all three of those numbers by 3, I get the 9, 12, 15 right triangle. Or if I multiply all those numbers by 2, I get the 6, 8, 10 right triangle. So that 3, 4, 5 right triangle is used a lot, and so sometimes you may just recognize that. You see the 9, the 15, you can get 12 without having to do the Pythagorean theorem if you recognize that. All right, so once we have those side lengths, now we're going to work with the ratios. So the ratios really depend on what angle you're referencing or focused on. And so these first three, what's our reference angle going to be? A. So if we're working with A, what's the opposite side? 9 is going to be the opposite. Just do abbreviate opposite. What's the hypotenuse? Always the longest side. And then this is the adjacent side. So it's really important that you use somehow, whether in your mind or just know what's my reference angle first, because the opposite side will change depending on what your reference angle is. And so sine is opposite over hypotenuse. And so we plug in those lengths. So opposite is 9, hypotenuse is 15. And so that's the sine. And if you could reduce your fraction, reduce that, we can divide top and bottom of that fraction by 3 and get 3 over 5. Okay. Cosine is the adjacent over hypotenuse. And so that would be 12 over 15. Reduced is 4/5. And the tangent is opposite over adjacent. Which in this case would be 9 over 12. And reduces to 3 over 4. Okay. Now, the next set, our reference angle changes. Okay, now we're going to make B our reference angle. And if B is our reference angle, then what's going to be the opposite side? 12. So 12 is no longer the adjacent, now it's the opposite side. And the opposite side becomes the adjacent side. Doesn't matter, the hypotenuse always stays the hypotenuse, but the opposite and adjacent change depending on your reference angle. Okay, and so our sine, opposite over adjacent, in this case that's, sorry, not opposite over adjacent, opposite over hypotenuse. So this would be 12 over 15, which is 4 over 5. Cosine adjacent over hypotenuse should be 9 over 15, or 3 over 5. And the tangent is opposite over adjacent, 12 over 9, or 4 over 3. Okay. When you look at angles A and B, the sine of A will always equal the cosine of B. You can see that. You're using the same numbers. The cosine of A will always be the sine of B. And the tangent of A and tangent of B are always going to be reciprocals of each other. So also, sometimes seeing those patterns can be helpful to you. In this next example, we have a special right triangle, the 30, 60, 90 right triangle. And I want you guys to remember 1, 30, 60, 90 right triangle. And I know it doesn't say 60, but how do we know it's 60 degrees in here? There's a 30 in there and there's a 90, and all three of them have to add up to 180. So this is a 30, 60, 90. And the 30, 60, 90 triangle that I want you to remember is this one. I want you to remember that the side across the opposite of 30, make that length 1. The hypotenuse is length 2, and opposite 60 is root 3. Okay, that's the one I want you to remember. Is that the only 30, 60, 90 right triangle out there? No. There's bigger ones, there's smaller ones, but they're all similar. I don't know if you remember math 2, you guys looked at similar triangles. They're proportionate to each other. And so these two triangles are proportionate to each other. And so you often look for scale factors. In other words, how would I move from which one's smaller, the one I drew or the one that was already there? The one I drew is smaller. So what would you have to multiply those numbers by in the smaller triangle to get the numbers in the bigger triangle? 7. And you can see that by just comparing the root 3 to 7 root 3, right? You see the scale factor would be 7. So what's A have to be? 7, because I multiply the 1 by 7. And what's C have to be? 14, because I multiply the 2 by that scale factor of 7. So if you look for that scale factor, what do you multiply by to get to one triangle to the other? Because they're similar, they're proportionate. But this is the 30, 60, 90, and those side lengths that I want you to commit to memory. Same idea with the 45, 45, 90. Now this does not look like a 45, 45, 90. What do you know about all 45, 45, 90 triangles? They're isosceles, huh? So A and B are going to be equal to each other because the base angles are the same. And in Math 2, there's something called the converse of the isosceles triangle theorem, which says if the base angles are congruent, then the side lengths are congruent. And that's what we have here. Now there's a 45, 45, 90 right triangle that I want you to remember. Only one. And that's, you're going to make those two side lengths 1. And if you make those two side lengths 1, then if you use the Pythagorean theorem, you end up with the square root of 2 for the hypotenuse. And so that is the one I want you to memorize. And every 45, 45, 90 triangle out there, bigger or smaller, will be proportionate to this one. And so you look for the scale factor. What do I have to multiply these numbers by to get these numbers? And you could see, well, that root 2 corresponds with 3 root 2. So we're gonna multiply all our numbers by 3. So what's A gonna be? 3, and B is also gonna be 3. And we have it. Okay. Those are the only two triangles you have to memorize, the 30, 60, 90 and the 45, 45, 90. If you get another triangle with other angles, you do not have to memorize that triangle. Okay, these are the only two that you need to know. So here we have triangles that we don't know. This has an angle 71 degrees in it. That one has an angle of 28 degrees in it. So these are not triangles that we have to memorize, but we still have to have some way of solving it. And the instructions here says solve for x using right triangle trigonometry. Once you have solved for x, use a scientific calculator. I'm going to take that use a scientific calculator part out. Okay, and even in your homework, don't do the scientific calculator part because your test will not. You'll not be using a calculator on your test, and I want you to practice without the calculator. Okay. So how do we approach a problem like this? Well, first, you have to pick your reference angle. So, 90 degrees can't be your reference angle. It has to be one of the others. So do we want to go with 71 or do we want to go with the other angle, which we can find? It's often easier just to go with what they've already given you. Okay, you don't have to. You could figure out what the other angle is and go with that one as well. But let's go with 71. So if that's 71, then you got to decide, okay, what's x in terms of opposite, adjacent, or hypotenuse? Because there's the three labels. X is the opposite, and 24 is the hypotenuse. And then the side we don't know is the adjacent side. Okay? And so because we don't know the adjacent side, we don't want to use it. We're not trying to solve for it. We're trying to solve for the opposite. So we need to use the opposite. We know the hypotenuse, so we're going to use the hypotenuse. And so which ratio has opposite and hypotenuse in it? This is where you want to make, you may want to remember SOHCAHTOA. Right? Sine has the opposite and hypotenuse. It's the only one that has opposite and hypotenuse out of those three. So that indicates which trig function you got to use. If I use cosine, that's adjacent, but I don't know the adjacent. If I use tangent, that also has adjacent. I don't know adjacent, so I don't want to use cosine or tangent. I got to use the sine, which is the one that has the two that one I'm looking for and the other one I know. And so I'm going to say the sine of that angle, 71 degrees, is opposite over hypotenuse, so x over 24. And now I have an equation that I can use to solve for x. So if I want to get x by itself and it's in a fraction, what's the trick? Multiply both sides of that equation by 24. Or what may be more helpful to you is you can put this over 1 and cross multiply. Works the same way. You can set it as a proportion. So I go x times 1 is x is equal to 24 times sine of 71. And put the 24 first. 24 sine 71 degrees. And there's your answer. That's as much as you can do without a calculator. You stop there. Yeah. Because you won't be able to use it on the test. And so I want you to practice. Like when you do multiple choice on the test, the answer will look like that. And you'll have to be able to find that. It's not going to be a decimal answer. Because most of the trig we're getting into is using the special right triangles, which every calculator has a different feature these days. Some calculators are more advanced and will give you that right answer, others won't, and it's easier just to say that no calculators for that. Okay. All right. So for this next one, just as I did in this first example, I want you to pick your reference angle. I want you to label that triangle, label the sides, opposite, adjacent, hypotenuse, and then decide which trig function that we need, sine, cosine, or tangent, to solve for x. Okay, so take a moment, set that up, just like we did in this problem, and then see if you can solve for x the way we did. All right, so in this triangle, you pick your reference angle. It can't be the 90 degrees, right? So you could go with the 28, or you could figure out what angle B is. It's easier to go with what's given to you, right? So let's go with the 28 degrees as our reference angle. That's your reference angle. Matt, which side is the opposite? Okay, side BC, which is 15, length 15. So this is our opposite side. And which side is with the x? That's the hypotenuse, the adjacent. Okay. So those are the ones we want to be clear on. The hypotenuse, as we said, is always opposite your 90 degrees. And then we're thinking, which of the three trig functions should we use? We don't know anything about the hypotenuse, and we're not trying to solve for it. We're looking for x, we're looking for the adjacent, and we know the opposite. So which trig function has the opposite and the adjacent? Only tangent. Okay, tangent is opposite over adjacent. And so we say the tangent of our angle, you gotta put the angle next to it, is opposite 15 over adjacent x. So if you got there, you're doing the right thing. Did you do it? Okay, so that's why we got to make sure you know the formula and make sure you label it right. Okay, once you're there, you can set up a proportion, put that over 1, and you can cross multiply. 15 opposite over adjacent. Okay. So when I cross multiply, I get x times the tangent of 28 degrees, and those go together, is equal to 1 times 15. And then I want x by itself, so one more step. It looks weird, but it's just a number. So you divide both sides by that tangent 28. Divide this by tangent 28, which is 1 there. Divide this by tangent 28. And so our final answer looks like this. X is 15 divided by the tangent of 28 degrees. And you leave it like that. Yeah. No? So if you use the other angle, what'd you get? Okay, so you found this is 62. Because you found it, okay, I need to figure out. And so now this would be the opposite side. And this would be the adjacent side, right? And so you write tangent 62 degrees is opposite over adjacent. Cross multiply, and you get x is 15 times the tangent of 62 degrees. You can do that. So both of those are correct. And if you had a calculator, you type this one in or type that one in, you get the same exact answer. Okay. All right. Questions? Any other questions about that so far? Is this coming back? This is what we did in Math 2. Do you remember this from Math 2? Okay. Okay, let's look at the next one. This is just like it. Okay. Let's all go with the reference angle of 65. And then let's label our sides. Okay, decide which side is the x, what side is the 8 root 5, what side is the blank side. Okay.
Oh, there's a square root in it. Can you take it out of the square root?
We'll look at it. We'll look at it. Yeah. No, don't square it. Yeah. Okay, so here's your angle. Here's your angle. Opposite. It's so see how this angle is created by these two sides.
Yeah.
The opposite's not those two sides. The opposite is across from that angle. It's the side it's not connected to.
Just whatever given angle.
Mm-hmm. Your angle that you're looking at, I'm highlighting. Okay. Our angle 65. Our angle 65 is created by these two sides that I highlighted, right? For every angle that you're working at with, those two sides are always going to be the hypotenuse and the adjacent. The side I did not highlight is always going to be the opposite side. So if you're having trouble finding out what's what, those two sides will always be the hypotenuse and the adjacent, the sides that make up that angle. And the hypotenuse is always the longest one. It's always the one across from the 90-degree angle. So this is always your hypotenuse, and this is our adjacent side. And this would be the opposite. Okay. 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 So which one do we not want to use? The hypotenuse, the adjacent, or the opposite? Okay, because we're not solving for it and we don't know it. So we don't want to know, we don't want to use the opposite. So then which trig function, SOHCAHTOA, which one do we want to use? Which one has the adjacent and the hypotenuse? Cosine. So we write cosine of 65 degrees is adjacent 8 root 5 over hypotenuse x. And then I need to solve for x. So what I'm going to do is I'm going to put this over 1, and I'm going to cross multiply. So x times the cosine of 65 degrees is 1 times 8 root 5. And then what's next? Divide both sides by the cosine, and you end up with x is 8 root 5 over cosine of 65 degrees. Okay. Now, if that 8 root 5 was on the bottom of that fraction, then we'd have to deal with that square root of 5. Remember, you can't have a square root in the denominator. But if you have a square root in the numerator, that's fine. Just leave it. That's the answer. Okay. All right, this last triangle here, x is our reference angle. Okay. So you still start the same way. Label what's what. The angles created by two sides, hypotenuse and adjacent. This is our hypotenuse. This is our adjacent. This is the opposite side way over here. Okay. You see why? The opposite and adjacent change depending on the angle you choose. Okay. The angle I'm focused on is angle x. So these are the two sides that make up that angle. And that's why I have hypotenuse and adjacent there. Okay. So that's what we mean by reference angle. Reference angle is which angle are you looking at? Which angle are you focused on? And then we got to focus on angle x because that's what we're solving for. Okay. Everybody okay with setting that up? So which one do we not want? Opposite. So which one uses hypotenuse and adjacent? Cosine again, right? So here's what this one's going to look like. Cosine of angle x is equal to adjacent over hypotenuse. Right? Well, I need to solve for x. Now careful. The cosine and the x are stuck together. It's not cosine times x. So you can't divide by cosine and leave the x there. They're stuck together. So there's something called the inverse cosine function. This is from Math 2 as well. Okay? And this is all you got to do. So let me just, before I get back to this, if I type into my calculator, if I type in cosine of 30 degrees, my calculator will give me 1/2. Okay? There's the opposite function, which is called the inverse cosine function. If I type into my calculator cosine inverse with a little -1 there, and I put 1/2 in there, guess what? It's going to give me 30 degrees. And so those are opposite functions. They're inverse functions. And so that's what I have to use here. I say x is the inverse function of 25 over 31. And that's my answer. Okay, it looks weird, but it's not the cosine function, it's the inverse cosine function. Okay? So whenever, listen to this. The only time you use inverse functions is when x is an angle. Okay? So only use inverse functions when x represents an angle. Okay, that's the only time it's needed. If you're solving for a side length, you don't need inverse functions. Okay, and that's what we did in the last few. Okay, not sure why we have 18 and 20 here. Don't worry about those numberings. Okay, so guys, here is the triangle, the 30, 60, 90 that I want you to memorize, right? Across from 30 is 1, across from 90 is 2, across from 60 is root 3. Here's another 30, 60, 90 right triangle. You don't have to memorize this one, but these two are proportionate. Which one's smaller? This one. So to go from a bigger triangle to a smaller triangle, you're going to have to divide these numbers by something, huh? And so if you compare, what do I have to divide 2 by to get to 1? So what's going to go here? 1 over 2, good job. And what's going to go here? Root 3 over 2, right? So if you think about dividing or multiplying is what you do to scale it down or scale it up. And so we're just scaling it down, we're dividing by 2. Okay? And now if we look at this picture here, and this is a quarter of a circle. We just studied circles, right? This is a circle with what radius? This is the center of the circle. I know my circle's kind of weird looking, but the radius you see is 1, huh? We call it the unit circle because the radius is 1. You guys have heard of the unit circle? Some of you have, maybe not. Okay, don't worry about if you've heard about it or not, but look at this triangle. What kind of triangle is this? It's a 30, 60, 90 right triangle. And it's one, we know the hypotenuse is 1. So what's our 30, 60, 90 right triangle is this one. So we have to scale it down to get to this one, right? So what's the opposite length? 1/2. And the adjacent length? Root 3 over 2. Okay. Now we're looking for the coordinate. We're looking for the x coordinate and the y coordinate. Well, what does a coordinate mean? That means like if you start at 0, 0, how far right do you go and how far up do you go to get to that point, right? So what's our x coordinate going to be? How far right do we go? Root 3 over 2. And then our y coordinate is the rise, how far we're moving up, which is 1/2. And so that's our coordinate, root 3 over 2 and 1/2. And so those are problems like the problems that you'll be asked to do on the homework. I need to correct, our homework is going to be worksheet 1. You guys see that on the bottom of your notes. Put that on the board here.